Assalamu alaikum boys and girls. Welcome back to the online classes. I hope all of you are fine and in good health. So better stay home and stay safe. May Allah bless us all and protect us from this pandemic. Our today's topic is modulus function. If we take the modulus of a number, if I take a modulus, these two lines actually represents the modulus, these two bars. Modulus of 6 is positive 6. Modulus of negative 6 is again positive 6. So modulus is always modulus of any number, whether it's a positive number or a negative number, its modulus is always positive. Modulus actually represents the magnitude of a number or the absolute value of a number. So modulus of a number or a quantity represents its magnitude or its absolute value irrespective of sign. So it always, modulus of a number is always a positive number. Suppose if I consider modulus of x is k is a constant which is a positive number. As we know that this x could be a positive or a negative number. We are considering a variable x, it could be negative or positive. When we remove this modulus, we are supposed to write or positive x is equal to k or negative x is equal to, we are not sure whether x is positive or negative. But instead of writing in this manner, we will be using a property. According to that, when we remove the modulus, we write positive x is equal to k or x is equal to negative k. There is no difference between these two expressions. If I shift this sign to the other side, I'll get x is equal to k. So whenever you remove a modulus to solve the equation, we will be writing it as the quantity inside the modulus equal to positive k and equal to negative k. So this is a property which we are going to use to solve the equations involving modulus function. Like if I have an expression to solve this modulus equation, I will write it as using these two equations, we will find the value of x. The solution of x, there will be two solutions. But remember, after getting those solutions, you must check whether they satisfy the original equation or not. So we will see that in our example. For example, if we have 2x minus 1 is equal to 3 and I want to solve it. Solve means to find the value of x. The first step, using this property, I can write 2x minus 1 is equal to 3 2x minus 1 is equal to 3. That expression inside the modulus is equal to positive constant and expression inside the modulus is equal to negative constant. Using these two equations, we can find the value of x as x is equal to 2 or x is equal to minus 1. But after getting these values, I must check whether they satisfy the actual equation or not. To confirm over solutions, 2 into, I'm using value of x, it is 3 modulus is equal to 3, which is true. Or if I use minus 1, it is also true. Modulus of 3 is 3, it's true. Modulus of negative 3 is positive 3. As we have discussed before, the modulus of positive or negative number is always positive. So both these values of x satisfy the original equation. So our solution is x is equal to 2 or minus. This is the basic technique, or we call it as the by definition. By the definition of the modulus, we solve the equation. Let's try another example. X minus 4 is equal to 2x plus 1. So by definition, to solve this modulus equation, I have to write to solve these two equations. We'll get minus 4 minus 1 is equal to x, or x is equal to minus 5. Similarly, I'll get x minus 4 is equal to minus 2x minus 1, so it will be 3x is equal to 3, or x is equal to 1. So we got two values of x. Again, we'll check whether they satisfy the original equation or not. Using this value, we'll get minus 5 minus 4 is equal to, so minus 9 modulus is equal to minus 1. It is not true. Because the modulus of a negative number should be a positive number. So this value x is equal to minus 5 does not satisfy our equation. So it is neglected. Let's try another one. One minus 4 is equal to 2 into 1 plus minus 3 is equal to 3. It is true. Modulus of negative 3 is positive 3. It is true. So our solution is x is equal to 1. So this is our basic technique to solve the equations involving modulus. Now we have few rules regarding the modulus. know A modulus and B modulus both are positive always. So if we take the square of both sides, we'll get A square is equal to B square. Because of the positive sign, their square will be, if A is greater than A is equal to B, their square will be same. Similarly, if A modulus is greater than B modulus, then their square will be in the same order. If A modulus is less than B modulus, then A square will be less than B square. Now using this technique, we can also solve the equations. We can also solve the equation involving the modulus. Let's see how. X plus 1 is equal to x. So squaring both sides, gives me find the value of x, I have to factorize this equation. It gives me two values of x. X is equal to minus 1 by 3 and x is equal to minus 1. Again, we have to check whether these two values of x satisfy the original equation or not. True. Minus 1 modulus is equal to minus 1. So first value satisfies. For x is equal to minus 1 by 3, I get so second value also satisfy. Therefore, our solution is x is equal to minus 1 by 3 or minus 1. If we have expression like you can arrange them as I have just separated the modulus, term with the modulus and without modulus. Now I can use whether the squaring method or the basic definition. I'm going to use the basic definition. 1 minus 2x is equal to 8 minus x, or 1 minus 2x is equal to minus 8 6. You can use both techniques, the squaring or the basic method. It gives me or sorry, it will be positive 9 positive 2. So we get two values of x. Again, we have to check whether they satisfy the original equation, this one or this one. If they satisfy, we have the solutions. So we get right. That's it for today. Inshallah, tomorrow we'll have the next lesson regarding modulus function. Thank you.